how to prove congruency. So if you're given two triangles, in order to prove that they're congruent, you would have to calculate all the different sides, and if you prove that all sides are equal, then they're identical triangles. Okay, automatically their angles will line up. How to prove two triangles are similar? You have two choices here. Number one, demonstrate all angles are equal. So using the F pattern, C pattern, or alternate angles or other angle tools that you learned last year. If you prove that all angles of both triangles are equal, then you can prove that both triangles are similar. And once both triangles are similar, you can also conclude now the sides are proportional. Or, if you want to prove two triangles are similar, you can take a look at their sides. If the sides are proportional, i.e., if they're double or triple or quadruple one another, then you conclude that they are similar. And once they're similar, you can conclude that the angles are now equal. Here's an example. Name the pair of triangles that are similar and prove why they're similar. So in order to name, we have to be careful about naming them in order. So we can see that this A corresponds to D, B corresponds to E, and C corresponds to F. And we can do it in any order that we want as long as the letters line up. So I'm going to do this in a little bit of a different order. I'm going to do triangle CAB is similar to FDE. So C corresponds to F, so I'm going to write that first, F, and A corresponds to D, so I'm going to write D as the second letter, and they wrote the last letter as B, so I'm going to write my last, B corresponds to E. And so we've named the pair of triangles that are similar. Done. Now to prove why they're similar, we have two options. You can either show that all angles are equal or show that all sides are proportional. So let's try the angles first. Let's see if we can try to show that all angles are equal. So we know that angle, so right here, we can use our knowledge of triangles to calculate what this is. So we know that all angles add up to 180 for a triangle. And if this is 40 and that's 30, that's 70. So 180 minus 40 and 30 will be 110 degrees. So we know that this 110 equals to this 110, but we have no information or ability to find out if this is 30 and this is 40, or this is 31 and this is 39, right? We can't tell. So we actually can't prove that they're similar using angles. So we have to try to prove that they're similar using the sides are proportional. Let's take a look. So to prove that sides are proportional, we write it like this. There's BC, the ratios, we're writing ratios. So BC, so side BC, side length BC, over EF. Let's see what that equals. So BC is 11.8, and EF, side EF, is 5.9, and we divide these two, that's going to be 2. So that is the first. We're checking if all sides are proportional. This is one ratio. Let's calculate another ratio. Let's take a look at AC and DF. So line AC and line segment DF. And we can see that AC is going to be 15. And DF is going to be 7.5. I just made a correction. So 15 divided by 7.5 will also be 2. That means this side, AC, is 2 times bigger than DF. So far, this side is 2 times bigger. This side is 2 times bigger. We have to double check and see if the third side of that triangle is 2 times bigger. So side AB over side DE. AB is 22, DE is 11. 22 divided by 11 is 2. Therefore, we have shown that all sides are proportional. Now, we've shown each of the ratios are 2. So we can state that now, since BC over E, this is the general formula, since BC over EF is equal to AC over DF, which equals to AB over DE, so that means all 3 equal to each other, which equal to 2. So that means, since all sides are proportional, therefore, the triangles are similar. Now you don't have to write this. You can say since the sides are proportional, therefore the triangles are similar. But please get used to seeing this formula. It looks like a very complicated formula, but it's not. It's just the sides, the ratios of each of the different sides. If you divide them, they all equal to 2. Okay, so this is a very common formula that we'll be working with in the next day. Okay, try the next example.